We shall be starting in 5 minutes.
Hello, I'm audible.
No, not this.
Hi, Pratik, I'm audible. Can you hear me? Can anyone confirm I'm audible or not?
Audible, sir. Audible.
Yeah, thank you for the confirmation, ma'am. So I'm just sharing my screen. Sorry for the delayed start. Hi, so good evening, everyone. This side Ayush, and in this today's webinar, I shall be covering on a hands-on guide to use Elucys by Realize Medical, which is nothing but a VR-based platform for doing the image segmentation and the modeling part. In this particular session, why we have kept this, we'll just start from the scratch how we import a particular DICOM data text, then how to particularly do the pre-image processing, image processing, and post-image processing. So without much delay, let's start. The first and foremost challenge that we face whenever we are working with any DICOM image data set is if we are working with 2D images, for example, an X-ray image, or even if single slices of images, we might not be able to visualize the structure properly. What issues we may face is we may be seeing 3D structure in the 2D view, which is not at all right for doing proper visual representation of the scene. We had traditional 3D image processing tools wherein we can model out the particular parts in the 3D, but still we didn't have the proper feel of as we aren't inside the particular virtual environment for the case. We can draw the particular structure out of the DICOM images, right from CT, MRI, but still to see inside the structure, to see inside the features, that used to be a difficult task. There need to be various tools that needs to be combined, like setting up multiple planes to slice across the data set, and then the particular measurement was also not that proper. So to counter that, we have the particular breaking the 2D barrier that we can directly now go inside the VR view of the same. Any DICOM data tag can be taken in and we can directly start the particular image processing for it. It's a very simple process as we will be dealing up with the upcoming slides as well as the live demonstration of the software. We shall be seeing it how the particular basic workflow looks like. So to cover up today's webinar agenda, we shall be first seeing how to import the DICOM images, convert that into 2D models. Then what are the different tools that are being offered, like the CREP tool through which we can easily navigate between the VR views? What are the other settings and menus options that we cater in? So these all gets covered in the precision tools. And the next part, but not the least part, is the collaboration method, how we can remotely connect to the same virtual environment, how we can do the segmentation. So keeping this for coming slides, what first bottleneck that we faced was that this we had multiple stack of images, but to see we can't basically predict the actual defect size directly while seeing the CT view. And whenever we are visualizing any 3D defect in a 2D view, that will probably cause error in our estimations. So the traditional method, we used to do segmentation using a threshold-based approach, wherein we defined a threshold range, and then we did the particular segmentation. But it's a time-consuming process. It took around 30 minutes for an expert users to properly segment a proper cardiac CT anatomy. To reduce out the time, we have this particular Elucys software, wherein what we can do is we can see the DICOM images, we can directly do the particular set of conversion into 3D printable models. Next up is the particular mentality that we used to do the particular 3D image segmentation using 2D cross sections. Therein, we weren't able to properly navigate between the surfaces. In some cases, the nearby other features, the bony feature or other metal artifacts that are being present in the dataset may also get covered. And the third point being that the software can be used for both soft tissue as well as hard tissue differentiation, because we can navigate to the specific point since it's represented by XYZ coordinate. So we can go to the specific point, we can mark up the region, and we can do the particular starting the sculpting part. So what we have is, let me just switch on my camera simultaneously so that, just give me a sec. Yeah, I think my camera is visible. Yeah, so what I'm trying to say is we have these controllers. This is my left controller and this is my right controller through which we would be navigating inside the VR headset. The particular device that I would be using in the live demonstration is a MetaQuest 2, which is directly linked to my laptop. So we have two versions of Elucys software. One is standalone one, in which once the project has been created inside the desktop, we can bring that project in the VR headset and we can navigate across the project. But coming back to the point, like to differentiate soft tissue and hard tissue segmentation. For example, when we are visualizing our data set, if this is the exact point, precise points that needs to be navigated, so we can go to the specific point, we can mark out the region and we can paint it accordingly. For example, if we need to highlight aorta out of the particular heart, so we can just select the aorta, we can paint the specific region, and thus reduces our time of computation since our region of interest is much more confined. The whole solution comes directly within the Illusis VR software. We have compatibility with various headsets like MetaQuest, HTC Vive, then Valve Index. So these are various compatible headsets which can be used to do the particular sets of modeling. Apart from pre-surgical planning that we can perform out in the software, we also have other advantages. Like whenever we are sort of doing modeling, if we need to do the convert into the 3D printable models that we used to have, or still we are having and we are using the 3D printed models. So what we can do is we can check if there are some complex anatomy that needs to be 3D print out. So that too is covered in Illusis. We can directly set out the cut planes and we can save the particular file as a STL file for doing the 3D printing part. Now, the next step is the visualization task. For example, if we are visualizing any structure, what we can do is there are multiple layers. For example, taking skin first, then taking the muscular region, then the orthopedic bone, and the small tissues that are being present. So we can highlight each and individual part out differently, and we can set out the opacity. So if we need to see the internal structure, so we can set the opacity to 1, and thus by reducing out the opacity, we can see a translucent structure for the whole object that we need to visualize. And one more advantage is we will exactly being calculating the 3D volumes of the data set that we are working on. So the dimensional accuracy is of the topmost priority once we are generating any sort of model. Now, taking into consideration the input formats that are being supported. So we have multiple input formats like we have the DICOM, that is CT, MRI, 3D echo that is being supported. Then we have the Nifty images that are being supported. Any sort of image files like JPEG, JPNG, TIFF. If we are having stack of that images, we can do the 3D reconstruction of the same directly inside the VR. Apart from that, we also have PAC server connectivity to ease out the connection and transfer of DICOM files across hospitals. We can use the PAC server. Then the third one is the EEP file, that is the Illusis project file that would be created once we have done any sort of work for any DICOM dataset. So we can easily do the particular importing of the EEP files, and we can work on the particular files directly to modify the particular data sets, to annotate the data sets, to set out memo. All the particular things can be carried out in a very efficient way. Now, coming on to how the particular launch screen looks like. So it's just a visual depiction. I'll show how the actual screen looks like in the live demonstration, but it's almost the same. So we have two windows, the first one being the create one and the second one being engage. There might be a doubt why there are two separate windows if we are using the same software. So to cover that doubt, what we have in the create mode is we have full creative liberty. So we have all the tools that are available in the software, right from the scratch to import the data set, then to particularly model out. All the particular tasks can be completed in the create mode. What we have in the engage mode is once the project has been saved using the create mode, if people just need to visualize the data set or need to do a slot modifications, like to have their own set of memo text to be written out or the audio to be put in, that can be done. Recording 3D video recording can be carried out in the engage mode. So we have two complete different modes to do the particular segmentation. Apart from that, we have one more advantage while we are working with Illusis is we can operate the software right in the desktop itself, or we also have the option to directly operate the software through only the VR headsets that we are having. So we have a complete control over which method that we need to choose it. Now, the conventional path is always to import the project with the following image dataset. It will have the default geometries of the particular DICOM, either being CT, MRI, and then we do the alignment. The software automatically does the alignment. We carry out the segmentation and to the most accurate value. So as it's the direct depiction of the DICOM images that we are having in the 3D VR, so the accuracy is around 99%. So there is highly accurate models that can be generated out. We have furthermore volume rendering options. So we can select out volume rendering for cardiac data sets. We can set out volume rendering for orthopedics data set, or even if we are highlighting any tumor part out, that too can be volume rendered in. So whenever we will be doing the modeling, we can overlap it with the volume rendering and we can check for its accuracy. So these are certain tasks that we have. Then if we are importing any structure, like any implant file that we need to position with the image dataset, that can be bring in, we can import the STL file, we can bring in the OBJ file or the Nifty datasets that we are having. We can align with the existing medical images. Once the alignment has been done, we can carry out our following process. Next up is we have a blank image workflow. When we have no DICOM dataset, if we just need to do the particular designing, so we have a free 6 degrees of freedom designing tool, which we can directly use using this controller. So we can do the freehand designing that further I would show how we carry out. So that can be done in a blank image workflow. We can set out the design, we can convert it into STL, and later on, if required, we can convert it into 3D printable models. Now, one more advantage that's of a huge use is we can fuse the data set of the same patient for CT, MRI in a single window. So once we get the particular results, that are the most accurate results that we can get, because we can easily identify out the soft tissues using MRI, hard tissues can be identified out of CT. Once that is done, we have integrated, so we will get the most accurate human body models to be prepared out while we are doing the segmentation. The next step is in the methods of the automatic registration. We are given with multiple sets of algorithms that we can select in to do the fusing. Apart from that, if the particular DICOM data set, many of you who have worked with the DICOM images may be aware that there are multiple series of DICOM data sets that are available. So what we can do is we can combine different series, we can fuse the different series to have the most accurate depiction of the dataset that we are working. Apart from that, we also have 4D CT and 4D MRI, functional MRI capabilities. So we can directly load in the 4D image dataset, we can work on it and do the particular segmentation part. Sorry. Pardon. Yeah. So next up is the remote segmentation. So this is one such advantageous features that we are having. For example, we say we don't want to do any segmentation. We need to directly generate a result out of the data set that we are providing. So for that, we have an AI remote segmentation technique. We can directly load the data set. We can select out which part that we need to highlight are the cardiovascular or the lung CT if we are working on that. Thoracic data sets that can be carried out. Any orthopedic segmentation can be done. And once it is done, we select out the particular parts. The process is automatic. It will use the total segmented model from 3D slicer to carry out the segmentation using the automated segmentation. Once we have generated out the model using auto segmentation, we can bring that in inside our view, and then we can correct out the surface, because the surface quality is not that accurate in the auto segmentation. So we can use multiple features like grow, we can do the smoothing, we can use the denoising. So there are multiple features that can be used to further correct out any segmented data that is directly generated using auto segmentation. Next up is the documentation and reporting. So what we can do is whatever data set that we are working on, we can do its metrics calculation directly. Like for example, any measurement that needs to be done, we can do point-to-point measurements, angle measurements. Apart from that, we have the options of calculating surface areas, volumetric data set, and all can be directly exported out as a PDF file. Apart from that, if we need to do 3D export, so we can have the option of exporting out the file into STL and OBJ. So either way, the particular files can be selected and we can export out our work, whichever is required. To come with the basics of VR interaction. So we have the options of using software either with our hands or with the controllers. For a beginner, I generally prefer using a controller because we have the controls of by using various buttons and triggers. So this I called side trigger, this I called front trigger. These are just the terminologies that we have said. Then these are the buttons A, B. Then we have a particular joystick that we use to navigate within the software. One more advantage is that when we are beginners, so we have a tooltips option, so that can be directly seen. We can grab and hold different objects. We can move one part apart from the rest of the part. For example, if considering a cardiac data set only, if we need to segregate out aorta from the rest of the part, so we can easily drag and drop to any point that is required. Then to create out peripherals, that can be done. To create out stent models, that can be done. We have predefined libraries from which the data set can be bring in site overview. And once it is brought in, we can do the further sets of modifications. We can just sit around our single chair and work in our virtual environment. So there is no minimum room size that is required. We can work according to our comfort, sitting on a chair, and we can easily navigate between the data sets directly. We can do the particular drawings, we can do the editing inside the 3D view. Now, the option is once we are doing the particular volume rendering, so we are given with multiple options. Either we can, if we need to use a ghost view. So ghost view, we need not to be afraid of. It's just a particular volume rendering. Once we press the trigger button and we are inside the view, we can navigate and we can locate the particular ghost view. Then we have the surface model. So that works on a threshold principle. Whatever threshold range that would be selecting, the surface that is present within the threshold range would be presenting in front of us. Then the third view is the volume rendering mode, in which we can select certain presets. We can set out the window level, window end level. And once the particular brightness and contrast has been set, we can visualize the result. Then we have the clip sphere. So we can go inside the surface to visualize the data set from inside. We can also directly put our headset inside any model and we can check how the internal surface looks like. Then we have the planes, so we can set out the planes in any direction. We can have multi-planar reconstructions to be done. Multiple planes can be selected, and we can go to the exact point that is unseen by our naked eye while we are working with the CT dataset. Now, how we work on with the painting of the dataset. So, soft tissue and hard tissues have different density metrics that we used to follow using the thresholding based approach. So, everything has a fixed value that is defined in which we can navigate and we can model out different parts of. Then, for example, if someone says that I need not to do the sculpting, I need to directly generate out the active structure, how we can do that? So that's very easy. We have a single active structure generation. So we select out the threshold range. Once the particular threshold range has been selected out, we can directly convert it out into any sort of structure. Now, to draw out any 3D structure that I had already told that we can directly do using the stylus. Stylus is nothing but our controllers that we would be using to navigate between the surface. But for example, there are certain artifacts that are being present. There are certain areas that we need to remove. So we have a direct subtract option through which we can remove out the region that isn't required for our set of workflow. Then we can also set the particular precision to 1 degree and 1 mm of value while we are navigating and when we are basically moving the objects inside the particular views. Now, whatever objects that we have produced out, what we can do is we can do the particular denoising. So any small artifacts, if present, we can directly remove out the artifacts. If we need to shrink out or erode the particular boundaries, we can go to the specific point, and once the particular seed point has been selected, we can shrink out the surface of the falling anatomy. Then we have the grow feature. If we need to grow out using our threshold range, so we can select a growing speed. Once a growing speed has been selected, we go to the specific point, navigate and grow out our structure to fine tune the model that we are working on. Next up is the particular precision control for planning. As explained earlier in the previous slide, we have the 1 mm to 1 degree of structure conversion. So whenever we are moving, so it's at most precise. We can carry out any implant design if we are having. We can position it to the most accuracy as required for our set of workflow. Then designing of object is also easy. The primitive tools that we have is cylinders, spheres, cubes to simulate implants or any surgical tools to do basically virtual surgical planning. Apart from that, what we have is we have a free surface tool which we can set out different control points, and once the control points have been set out, we can design the objects as per our imagination. So whatever you can imagine, you can draw that out directly in the VR view. Next up is the measurements. So we can have various measurement tools to be directly used in the 3D. We can do the length measurement, angle measurement, even the curvature measurement can be done. Then we have the surface area and volume measurements. All gets completed directly and computed directly inside the VR view. Next up is the 3D markup. So if we need to annotate any data set, if we need to create out a memo for certain data set, that can be done The pre-surgical planning can thus be planned very efficiently, marking out the specific points that needs to be considered while we are modeling out any structure. So all these tasks can be done. Then we have the most advantageous point is collaboration mode. For example, I am sitting here in Delhi and someone wants to connect from Chennai. So what they can do is we can come into the single virtual environment, we can discuss out the cases, we can share the databases, and all is secured in a single connection. So who has our key can only access our virtual view, and we can basically come and we can see others collaborating in a single view and have a shared experience within one user and another user. We can do various sets of inputs. We can have various options to control what other can do. So we have options like editing. So they can edit and access the data set. We can also mute them directly, or we just need to engage them. So if they need to highlight certain points, so that points only would get highlighted. So that's the annotation method that we have. So setting up session is quite easy. We every time we need to create a session, we need to just click on create session and then share out the particular key that is being generated in a join session option. Once the particular join session has been generated out, we can just carry out and generate the model and do the particular host control along with. The next step is the synchronized setting. So whenever we are interacting with the data set, we can directly we can check out the sizes, we can check out any data set. Even the desktop users can basically interact with the direct viewer view. We can do various sets of modifications, whatever changes are required to be done in the desktop version can be carried out. Next up is the security and privacy. So all the data set that is being operated is in a remote system. So it keeps the particular security at topmost priority. No data set gets leaked, and we can work on individual systems directly. Next up is the hardware requirement. So we require a decent hardware for software to work efficiently. The minimum requirements being i5 or i7 or higher processor with a minimum GPU of RTX 3080 that is required. Then we require a link cable or any USB Type C cable that can be used to connect the VR headset with the desktop that we are using in. So we need to require a link cable. Generally, link cable is much more larger size, but since the space between the system and me is quite less, so I'll be using a short normal Type C charging cable through which we can connect out the headset with the system that we are operating on. Next up is the Illusus Go mode, that is the standalone mode that we have. So whatever projects that we have created, we can export it out as AEP file, and then we can directly open it in a remote machine, like directly in the VR headset, and we can use various features of whatever features that are present in Engage can be used in. Summary. So to summarize this particular part out, we can just do faster segmentation, we can do the most precise segmentation, and we can do the collaborative segmentation directly within our virtual view. So without wasting much time, I'll directly starting up with the live demonstration. Meanwhile, if someone has any queries till now, they can let me know. Just give me a sec. Yeah, so I'm just turning on my camera. So this is the VR headset that I would be using. Here, how to connect the headset. So we can directly plug in the cable in the C port over here. That the other end needs to be connected at the other side in the desktop that we are operating. Once we have done this, we can directly put on the headset. So we have two modes to open the software. Either we can use our desktop version, or we can also directly operate and open the software. So to open the directly software from the VR headset, once we connect the link cable, we go inside the virtual environment, and from here we have direct option of opening the software. I'll just reconnect my headset. Just changing my cable. To connect the headset with the system, we need to open the Horizon link, devices. We have the system as active, but it's not running, so I'll just click on link. Once that is done, we'll have to click the launch. Yeah. So once we are inside the headset, I'll directly opening the software. So I hope you would be seeing the same in the desktop. Just loading out. Yeah. So whatever I'm seeing in my VR headset, you are seeing in the same inside the desktop version. So how we do is we just click on the create. We open out the project. Once the project view is open, we have all the particular folders that we are working on. So we can select out any of the DICOM images to basically create a new project to import the DICOM images. What we can do is I'll go from the desktop version, clicking on new project. We can just click on the select path, and here we can select out any path that we are having. Selecting the folder, saving the file as A4. Once that is done, so now what the software is doing, all the particular series of dataset that is being present inside the folder is getting scanned. It's not a single series of dataset, it is a multiple series of dataset that is being present with 40 dataset as well available for the following image dataset. So the higher the amount of series that yeah, so the higher the amount of series that we would be taking in, higher would be the computation time to bring the data set. So here is all the particular data set that we are having. So here we can select out the following series that we require. Here's the 4D CT. So it's a 4D functional CT of the following patient that can be taken and that can be modeled out. We can also have a stationary series. So here we can select multiple series also. So for example, I am taking this as primary series, and here I will be taking it as a secondary series. Once it is done, I have to name the project as something. Once that is done, we just need to click on create, and it will start copying the following. Yeah, so once it is done, sorry, I'm receiving a call, just give me a second. Once the copying is done, we can directly bring the dataset within the VR view, and we can work on the dataset directly inside the VR. So it will take some amount of time, around 1 more minutes, for the dataset to be loaded. Once it is loaded, we can navigate back into the VR view, and once we are inside the VR, we can open and we can run out any image data set that you're working. 50% that has been imported. Whenever we are taking the 40 dataset, it generally takes time for any normal series of dataset. It hardly takes around 5 seconds for the dataset to be loaded. Once it is done, the first and foremost thing that we need to clear once we have loaded the project is we need to click on follow point of view in the VR headset. Why we need to do that is so whatever I am seeing inside my headset, you can see the same. So there's an option of follow point of view inside the desktop. How to do that? I'll directly go click the follow point of view. Now, whatever I would be seeing inside the dataset, so once I am navigating within the dataset, that can be easily visualized in. Here we have the menu options. So this is my right controller, this is my left controller, which we would be using to navigate between the datasets. How we do that? We will be just clicking over here and we have whole menu option. So while clicking the particular B button in my right controller, I will be having this whole menu options. In that I have a grab option, anchor, precision, move. So when we are dealing up with surface, we can use the following tools. Then we have a configuration table. So here to configure out surface at my height, what we can do is we can click on the quick surface. Once a quick surface is done, this is my trigger that I would be using to pressing down and placing the object at my height level. So I'll be probably keeping somewhere around here, and you can see the particular projection has changed to the falling height that we have selected. To increase and decrease out the size, what we need to do is we need to press out both the trigger buttons at once. Once it is done, we can increase and decrease the size. So we can take the size to humongous amount and we can select out and set out the size accordingly. But still, some of you might question that only a single slice of image is available and seen in front of our eyes. So what we can do is we need to visualize the data set. So as mentioned in the presentation also, we have four modes. So we have off, in which this is the ghost view that we are having. So here we can just see a quick volume rendering. It doesn't take much memory, so it's a quick volume rendering. When we have a off mode, so once we will click on off, we won't be seeing the particular volume rendering. So once we have clicked on off, we won't be seeing the particular ghost view. Then what we have is if we click on the surface, so a quick surface is generated using the particular threshold range. So if we just need to quickly visualize the data set, we can set out the threshold range, and using the threshold range, we can select out and we can mark up the particular region. Here, when we set out as clippable, so we can also navigate within the set. So I'll just add a plane, selecting this as active plane. So to visualize the particular structure from inside, we can just clip down directly in the volume rendering too. So if we don't have sufficient time to model out the data set, although it takes around 2 minutes, less than 2 minutes to model out, if we need to visualize it in directly in the data set, so that can be done. We can set out any number of clip planes, and then we can see the internal structures once it is set as clippable. Other option that we are having is a volume rendering, so we can select out various modes. So we have various presets like CT soft tissues that can be selected. So hollow structures can be visualized very efficiently if it's set as clippable. Then cardiac hollow is also there to directly visualize and across the cut plane. I'll just select out plane, cut it, and we can see the particular volume rendering and see the internals of the surface directly. So this is the volume rendering options that we have. To use the software most efficiently, we can always work on a ghost based principle. And now comes the main task. We have brought in the data set, but how to basically model that out? So to do that, I'll be clicking again the B button in my right controller. Once I do this, I will be having a menu option in front of me. Now here's an option of modeling. So here is an add. But before add, first we need to click out and create an initial structure, which needs to be created while pressing the Y in my left controller. We have the full menu option. So we have a project. So all the projects that we are working on can be seen from here. Then we have a navigation. So to translate the data set in any of the direction, that can be done using the navigation option. This is the images section that I had already shown. If we need to see the dynamic images to see the particular changes that can be done, and we can have the dynamic visualizations to be considered. This will take as live image, and we can do the particular dynamic image visualization. We can also see that in the particular coast view, even in the surface view that can be seen in even the volume rendering, the particular parts can be seen out. So for the 4D itself, we have the following support. It takes higher amount of RAM. The system that I am currently operating on is a 16 GB RAM. So if we have a 32 GB RAM system, the software would work more efficiently, and a little bit jittering that is present will also get removed. So if we have selected a hollow cardiac and we need to directly visualize across the plane, so we can select out the plane and the hollow structure can be directly visualized and we can identify out the surface. And this is a 4D data set that we have worked on. It's quite efficient and it's quite trustable while we are basically developing out the model. I'll switch off to static, taking the first slice itself. Yeah. Once it is done, I'll convert it into ghost view both. Now to start up, we have shown the images, we have shown the projects, navigation, images, planes. Next up is model. To start up the segmentation, the first task that we need to do is we need to create a model. How to do that? Once we have opened this tab, we need to click on plus. Here again, we need to click on plus, and now we need to select out the level of details that is required. A high is generally recommended if we have a lower set of configuration of the hardware that we are using. Once it is clicked, we need to click on both create 2D and 3D. I'll resurface it so that now we have this particular view. Now we have this particular view. This is our data set. We need to start up with the segmentation part. So how to do that? We have the option in the modeling. We have add option. Now there's a table of the following options that is available. So we have a use threshold. We need to select out a threshold range that needs to be modeled out. So as mentioned earlier also, we have two methods of segmenting out. Either we can directly apply the following feature to an active structure, and whatever we were seeing in the volume rendering will get as it is converted into a surface structure for us. Before that, we can also click on reduce noises to remove out the small noises that are present, that might be metal artifacts or any distortions that are present in the dataset. Once it is done, we need to click on apply active structure. So this is the initial and the most easiest way to segment out the whole anatomy within seconds. So we have done the quick segmentation for that. But there are many parts that are present which aren't required for us. So to remove, for example, the ribs, the wires and all, how we can do that? We can click on subtract, and then if we will move the particular head backwards, it will increase the brush size. It will be moving it forwards, it would decrease the brush size. To remove out larger objects, we can use this particular option. We can see a little bit of jittering since we have also loaded the particular 4D data set with us. If we are only working on a single 3D data set for a single series of data, it won't jitter that much and we can directly work across the image data set. Once it is done, we will slowly remove out the data set that isn't required. All the artifacts are easily removed and the segmentation task gets completed within few minutes. So around 2 to 3 minutes, 2 minutes of time is required to basically clear out the data set and to model the particular surface efficiently. Even if we have missed certain surface, like for example, I was removing this and I have removed the part of heart out too. How to cover out this particular mistake is we have a grow feature. So we will be selecting a grow. Once it is selected, we can easily navigate and we can grow out the particular structure that have been missed by us. So this is one such easy way in which we can basically take out the part if removed by some mistake. Here we will be removing out all the particular region that isn't required. And this data set I'm working on for the first time. So whatever time I would be taking, the same time others would also take to do the segmentation. So the process is user independent. It's a quite easy process. There are no many tools. Only we need to use this. What we can say, we need to use our hands to do out and carry out the segmentation. To switch between add and subtract, we just need to click on this side triggers in the left that we are having. To increase the size, we need to use the right side triggers. Once we have done subtract, orange one is for subtract, green one is to add the regions. We will directly remove out the surface. Yeah, so the noises are also removed. I'll fasten up the process. Yeah. So here we can see a very clear cardiac model is generated within seconds. To remove out all the other noises that are required, we can do it the later stages. To grow the regions that have been removed, I'll be selecting over here. Here we have a grow and shrink speed. So we can also select out a grow and shrink speed to basically cover out the surface. Here also some regions of aorta have been missing. I'll just select and reduce out the size, and then I'll start growing the falling surface to the minimum amount. We can also use an add feature, but grow would be more precise as it would carry and store better set of information. So it uses seed point. So whenever we will be selecting out the seed point, we can go to the specific point and we can grow out the structure. So this way the most accurate representations can be generated. Once this particular structure have been carried out, now what's the next step? So for example, if we need to do and carry out a particular 3D printing, here we have like grow, we have the shrink feature. So to remove out the surface at certain points, a particular shrink feature can also be used in. Now, once it is done, we have generated out a volumetric model. What's our next step? So to do that, we can go inside the planning tools. Before that, we can go into the operations. And for example, if we need to generate out a hollow structure of heart from inside to see the internal features, what we can do, we need to just click on operations. Here we need to apply a shell operation. Once it is done, we select out the expansion length around 0.8 to 1 mm. We have selected the active structure as structure 01. So here we can also rename it. So heart, I'll just set in. Once it is done, going into operations, now the active structure as heart, operation as shell, clicking on execute, and within few seconds, the particular hollow structure of heart is generated. So this is the hollow structure that has been generated. There are some noises that can be later on removed. But coming back to this models, now I'll just disable the old model while directly toggling on the 2D and the 3D views. Once it is done, to see out the internal surfaces, I'll just add up a plane, clicking over here, clicking on the active plane, and this way we can easily select and see the hollow structure from the heart from inside. So we can cut down across any planes. For example, if we need to split up this part into two parts, one part over there around the plane and one part over here, we have selected a clip plane. We'll go again into operations. Now we have also got one more option as clip plane operations. Selecting heart, operation as split, since we are splitting this particular part out into two different regions. Once it is done, I'll just directly click on execute, and boom, the particular process got completed. It got split into two different parts. We can just see over here. I'll just delete this particular pane, and this way the particular models have been generated. Now, for example, if we need to do the movement, we can also click over here, set it as movable. Once it is set as movable, we can remove and we can segregate out different parts directly. We can place it over here again, and to see the internal surfaces. Since we have applied it on the particular heart operation, if we would have applied it on the shell, I'll just show that. I'll delete this for now. So the surface got covered as we were working on the particular older model. We will go over here, clip planes, selecting out new plane, setting out over here, operations, split, shell model, execute. Yeah, now it got split into two different models that we can see over here, deleting out the plane. So now if I'll set it out as separable, going over here, set it as movable, movement, movable, done, removing this part out. Now we can see the hollow structure. So this way we can basically cover out and cut the particular planes into multiple sections. So a uh, three planar model, two planar models can be created. And once the particular models have been created out, just give me a sec. Deepak. So sorry for the interruption. So coming back to this particular model generation, here we have the particular model available. We have split it into two parts. Similarly, we need to have a three surface model generated. That can be done. I have one pretend model out of the same that I had worked recently that can be converted and the model can be created out. Once it is done, uh, we can set it, we can convert it into the STL files for doing the 3D printing that I'll show directly from desktop how to do that. Now, coming back to the segmentation part, I'll delete this particular parts for now, taking this model as intact. Now, there are multiple options that we can do. For example, if we need to do the splitting of aorta from the rest of the part, we have a split operation. We will be again using our right controller. Once the right controller has been selected, we will be select the option of select. Now we need to just select out the region that we are selecting active structure. Okay, I'll select it as an active structure, and now I'll select out a region that needs to be selected. Once a small region has been selected, now the best option is to use a seed feature. So once we are using this, we have to now use the grow selection. So we have selected this region, and now using grow selection, we can easily mark up the region. So the particular segmentation to split up into different parts, it's of the most precise value. We go over here, we slowly cover out the regions that are present, and we need not to worry if some region from the different part gets also covered, so that we can later on be removed out. So this way we will grow the region equivocally over all sides, and since now we can create it directly from select, so we can just highlight this particular part out. Yeah, once it is done, what I'll do is we have this option of split. So once we will click on split, so it has splitted these two parts separately. Now in the models, what we would be saying, we have this intersection one where we can set it out as movable, movable, done, and we can just segregate out from the rest of the parts. So here we have the aorta and then we have the rest of the heart for us. This is one such way where we can split up multiple parts. Even if we are working for an orthopedics data set, for example, a pelvis to be taken for example, we can easily segregate out left pelvis, right pelvis, sacrum, then left femur, right femur in a very efficient way and the most easiest way. These are the basic operation that we have. Now, for example, if we need to use the designing tool. So in the planning tools, we have a stent planner. Once we will click on enable, we will be getting the particular stent model with us. I'll be just clicking over here. We can set out the length. We can set out the flare size, the dimensions. Once these all have been selected out, we can bring and we can place it according to our image settings. How do we do that? We also have the full library. We can select out any stand size. We can mark it up. Once it is done, I'll go into the design tool, edit, models, planning tools, setting out enable, show reference plane, and now we can set out the following region. So we'll create a reference view. Now as J1, once a reference view have been selected out, we can select it, we can play it, camera position to specific points that we need to do. For example, if we need to set it out over here, I'll convert it, change the dimensions. So now whatever regions that we are cutting, we can directly visualize over here using the reference plane option to see the particular surface option. And now whenever we need to place, we can just bring it down. I'll set it as movable. Yeah, once it is done, we can just set it as movable. Now once it has been set, close this view. So once it turns from gray to green, we can then place it accordingly. Then we can set out the flare length and all. So any stunt that needs to be planned, Our patient specific stent can be planned and that design can be completed most efficiently. We just need to go inside the structure, place it, selecting out the surface. I'll just close out the reference view. Close. I'll delete this particular part out. Closing. So we can just click over here, going inside the surface. We can set it according to our specific points. Once the particular points have been set, we can just convert it out into printable models. Apart from that, if we need to do a free design, so how to do the design? Here we have a design option. Here we need to click on edit. Once we have clicked on edit, we have an option of create new. Here we can start designing right from scratch. So any primitive shape can be selected. Like for example, any rectangle prism can be selected out. We can also set out dimensions manually. So, so the dimensions can be set out over here and any surface can be created. This is a very primitive size of a rectangle prism. If we need to set out any other cylindrical structure can be created, height width can be changed simultaneously. So any surface can be marked up. For example, if we need to design a stand from scratch, what we can do is we can click on cylindrical surface, we can hollow it out. We can do the particular designing pattern, whichever is required, the lattice pattern that has been required. Once it is done, we can convert it out to the following points. Apart from that, the best feature that I like over here is, I'll just delete out this particular for now, is the particular loop and the surface one. So once we are creating a loop, so here we have the full control. So any designing can be done freely directly in the VR view. So we have multiple control points that can be selected and the particular design can anytime be converted as a uh, 3D design. So whatever complex implants or any other objects needs to be designed can be designed directly. For example, if we need to design any surgical jigs, that can be done. We can just import over the surface and we can mark up accordingly. For example, I'll delete this one, create new, taking a surface option. Here I have selected this particular surface. So we can create the exact replica and then we can set out the points also. So for example, if we need to set out the part as convex or convex, we can select it out. Once it is done, pardon. So this way the surface can be selected up. So here any free surface can be drawn out. Once the surface has been drawn in, we can directly convert it into design. So we have an option of convert to structure and whatever free designing that we have done has been converted into structure that can also be seen in the models one. I'll just disable this, enabling this part, set it as movable and that we can bring. So we can design any surface and that can be modeled out directly. So this is the basic view what we get inside the VR. Now I'll just switch on to some of the features that we have in the desktop version. To do so, the first point is that we have the auto segmentation. The auto segmentation can be done using this remote segmentation feature. I'll just click over here on the remote segmentation one. Here we can select out a part. For example, if we are doing a cardiovascular auto segmentation, selecting out the region CT, static, pending. So it takes around 5 to 10 minutes for the segmentation to be completed. And faster than that, we can directly do the segmentation in VR. So we prefer general VR, but if someone needs to rely on the auto segmentation, so that too can be generated. So first is uploads the data set. then the segmentation is performed remotely, and then it downloads. So the total segment also requires a network connection, and rest of the software can be directly be used without the network also. So this way, the particular modeling auto segmentation is generated. Apart from that, whatever structure that we have generated, for example, the shell one, if we need to do the export, how we can do? We can select out the file type as STL, OBJ, or the segmented image. Once the particular file type has been selected, we need to select out the folder in which we need to do the export, and the export will be converted as a STL file. I'll show one example, selecting the folder, and the export gets completed as a STL file. So this is the easiest way by which the particular model can be exported out. Apart from that, whatever we are seeing, we have the full control. So this is a tooltips one. So I'll just put on my headset again. Yeah. So once we enable the tooltips, now you can see what different buttons and different controllers in my headset offers me. So for example, if I need to go inside the menu, a stylus mode, so I can go inside the stylus mode. Inside the menu panel, we can check how which tools would work to increase and decrease the size. Once the particular segmentation has been done, we can go inside the view and we can just click over here to whatever size that is required. So this way it can be generated out. Then these are just the features, extra features that we have. Similarly, we have a direct tutorial guide in the VR itself. So whosoever needs to learn the software can directly learn through the VR alone. Whatever project that we are saving, we can save it as an EEP file. And once the EEP file has been created, we can share it across other users of Elosis. Apart from that, whatever sessions that we have created, whatever segmentation have been done, can be recorded in the VR view. And once the recording has been completed in, we can generate out the models of the same. Here we have the scenic visualization also. We can generate and we can do a radiograph, so simulated radiograph. I'll just disable the follow point of view. And for whatever CT data that we are generating, we can set out the intensity over here. And we can set it, generate a virtual X-ray of the same. This is just the basic settings and basic overview of the software. Anyone has any queries till now? I am open to the queries.
Hello, sir.
Yes, ma'am. I'm audible.
Uh, sir, we are belonging to the academic institutions,
Yes, ma'am.
biomedical engineering department.
Okay, ma'am.
In what way your product is useful for our academic purpose, sir?
Okay, ma'am. So, ma'am, is anyone working in the biomechanics field or medical image processing field?
Mm.
So, what our software can do is, if a particular person needs to develop patient-specific implants, that can be done. Apart from that, if someone has already designed any implants and then need to do the particular positioning along with the image dataset, so that too can be carried out. And the third way is all the particular biomechanics simulations, then all the sets of medical image processing. Medical image processing is a very growing field that we are seeing. There are continuous upgradations in the field. There are new innovations in the field. So the software can be learned in, and once it is done, there are you can check over the web. There are many research papers that have used the softwares like Elosis and done the 3D image reconstruction of the CT dataset, MRI dataset to detect out any anomaly, any tumor detection can be detected out. So there are various criteria that can be researched in. So it has its use case in the research field as well now for academics.
But it seems like just a demonstration like that, sir. It is not code writing like that, isn't it? Can we give this one for experimental purpose for the students? Any project or regular class experiments?
Yeah, it has an evaluation version. If you require, we can share out the evaluation version with you.
It is not like that, isn't it, sir? Writing the code
Yeah, we can't write our own codes
MATLAB,
within the software.
platform like that.
MATLAB is completely different from it, ma'am. It's specifically
Uh,
focused on medical image
Yeah,
processing
there
and
the students are writing the code
yes,
and they
yes,
are
I
doing some
understand.
experimentation like that. But
Yes,
here,
ma'am.
not like that. This is just, I mean, a demo purpose only, isn't it, sir?
Yeah, it's a
In
commercial software, ma'am.
education,
It's a commercial. Yes,
education.
yes, ma'am. Yes, ma'am. It's not like MATLAB. MATLAB is completely different software from Ulysses.
Mm.
MATLAB has its
In
own
what way
functionality.
it is different from your product is different from 3D slicer? There is one product, 3D slicer is there, no?
Yeah, I know about 3D Slicer, ma'am. So we have the VR integration and it's very much optimized. So for example, the same data set that I had shown, it will
Uh,
take around 1 hour to do the segmentation, to do the particular modelization, 1.5 hour to 2 hour. And that too, the model quality would not be that accurate as it is generated over here. 3D Slicer is a good tool, but it's an open source tool and it doesn't come with a VR facility as of now. So we
Yours
have
is not open source. Yours is not open source.
it's a commercial software, ma'am. It's a commercial
Commercial
software.
software. How much, sir? How much?
Ma'am, the price
Approximately.
the sales team can contact you with the pricing. I am just an application engineer, so I don't have any idea regarding the pricing and all.
But
I'll ask the
your
sales team to
software
contact
is
you.
combined with your handset and headset, isn't it, sir?
We can
This
we
is
can we can
VR
provide with
based,
the
isn't
headset
it?
also. If you have the existing headset and existing device, then the it needs not to be delivered. But if you require with a single quotation and all, so I think that we can provide along with the headset and hardware.
Can you send your contact number, sir? And who is the
Sure, ma'am.
organizer? You are the organizer or you are just a speaker?
I'm the speaker, but I'll just share out my number. You can contact me. I'll share out the details.
Okay, okay. So we are registering on Google form. So
Yeah,
the
we have got your details, ma'am.
organizer knows that I am Dr. D. Selvadi
Okay, ma'am. I'll note down
from
the details.
Methuselah Engineering College, sir.
Okay, ma'am. Okay. I'll note down the
I
details.
registered the Google form.
Okay.
And if possible, can you send your number to that mail ID, sir?
Sure, ma'am. I'll definitely share.
Yes. Organizer know that Google form. I am Dr. D. Selvadi.
Okay, ma'am. I have
My
noted the
mail
details, ma'am.
ID as well as the WhatsApp number is available.
Okay, ma'am.
Please send it,
I'll,
sir.
I'll,
We will
I'll
consider.
definitely ask
We will
this.
consider.
Yes, ma'am. I'll definitely ask the organizers.
Yes, yes, sir. Yes, sir. Thank you, sir. Thank you.
Thank you, ma'am. Anyone else has any specific query? So I think there are no queries. I'm just dropping down my contact as well as my email address. So one can contact over here. And I'll just write down my email. So I'm just dropping my contact as well as email. So one can contact over here. So thanks everyone for tuning in. I hope you enjoyed the session. If you have any queries, I have just texted my details in the chat box. The WhatsApp number as well, college number and the email have been pinned down. So you can contact me over there. So thanks for tuning in. Thank you everyone for joining.